Pluto is a faraway planet that used to be considered one of our main planets, but recently Neil deGrasse Tyson and Michio Kaku have been talking about Pluto again. They think it might crash into Neptune. How could this even happen, and what would the result be? Is this just some weird space thing? Or is there something else going on? Let's check out what could happen if Pluto and Neptune ran into each other. Pluto used to be a planet, but now it's a dwarf planet thanks to its weird orbit. Scientists are still super interested in it. Tyson and Kaku are worried that Pluto's orbit is getting too close to Neptune's, and they think they might crash, which could be bad for Earth. But how could something like that happen? Pluto's trip around the Sun is different than any other planet. It takes 248 years to go around once. That means it hasn't even made one full circle since we found it in 1930. Plus, Pluto's path isn't a circle. It's more like an oval, and it's tilted at a weird angle compared to the other planets. Here's a crazy thing. For about 20 years of its orbit, Pluto actually gets closer to the Sun than Neptune. So why haven't they crashed? The answer is gravity from other planets. When people noticed Pluto, they tried to figure out its weird path. Unlike the other planets, it's tilted and oval-shaped, and it crosses Neptune's path. But Pluto's orbit is steady, which shows just how complicated space stuff can be. There's this thing called the three-body problem that explains how Pluto, Neptune, and the Sun mess with each other's gravity. It's hard to guess where things will go, but this problem explains how Pluto's path, Neptune's orbit, and the Sun's gravity all work together. Things like azoth libration, scope libration, and Vick-Zip oscillation are important for understanding this. According to scientists, azoth libration means that when Pluto crosses Neptune's orbit, it's always far enough away that they won't bump into each other. Scope libration means that Pluto is above or below Neptune's orbit when they get close, which also keeps them safe. Vick-Zip oscillation is how Pluto, Neptune, and the Sun pull on each other and change how they move. It helps explain why Pluto's orbit is so strange, but it also keeps it steady over time. All of these things help keep Pluto from crashing into Neptune or going off course. The three-body problem helps us understand how these forces change based on gravity. By studying this, scientists can learn more about Pluto, our solar system, and other planets. In the late 1980s, mathematical models showed that Pluto's orbit is still a bit wild. Small changes could make a big difference over time, but Pluto's orbit has stayed pretty stable for a long time. New models have helped us figure out how planets like Neptune, Jupiter, and Saturn affect Pluto's path. Neptune and Pluto have this thing where Neptune goes around the Sun 3 times for every 2 times Pluto goes around. This helps keep Pluto's path steady. But Jupiter's gravity is also key. It's strong enough to keep Pluto on track for billions of years. So Neptune, Jupiter, and Saturn all work together to keep Pluto safe. These things are super important for keeping things in order in space. Without them, our solar system would be a mess, and things like Pluto could crash into other planets or get thrown out of the solar system. Understanding Pluto's orbit is important, especially since people are talking about it crashing into Neptune. It shows how even weird orbits can be steady because of complicated gravity and how things move. We need to keep watching and learning to understand our place in space. Space is weird, and Pluto's weird orbit proves it. This path depends a lot on where it starts, and even tiny changes can mess things up in the long run. Scientists use computer models to figure out how Pluto moves. They use math to show how Pluto and other planets, like Neptune, pull on each other. By changing small things in the models, scientists can see how even tiny changes can make big differences. In the 80s, these models showed that Pluto's orbit can be pretty chaotic. Even with things like azoth libration and scope libration, a small change in where Pluto is or how fast it's going can make its path totally different over time. But even though it seems crazy, Pluto's orbit has been steady for billions of years. This suggests that there's some kind of order to Pluto's path, even if it doesn't look like it. It's hard to guess what will happen with chaotic orbits like Pluto's. We can't be totally sure about long-term predictions. Mathematical models are cool for figuring out what might happen, but they also show that we can't predict everything perfectly. These models depend on having the right starting info and knowing how everything pulls on each other. Even a small mistake can change the result a lot, which makes it hard to predict things exactly. Chaotic orbits like Pluto's remind us that the universe is always changing. We've learned a lot about space, but Pluto's orbit shows that there's still a lot we don't know. Understanding how giant planets' gravity affects Pluto's orbit helps us understand the solar system better. It shows how each planet affects the others. So why are scientists suddenly worried about Pluto crashing into Neptune when all these things are keeping them apart? Neil deGrasse Tyson, who helped make Pluto a dwarf planet, thinks it's not a bad thing. It just means we're learning more about the things that go around the sun. He thinks Pluto's weird orbit shows that we still have a lot to learn about space. He's interested in things like Pluto and Neptune crashing because it shows how wild and unpredictable our solar system can be. His work shows that the more we learn, the more questions we have, which means we need to explore more. Michio Kaku focuses on the unpredictable forces in space. He can explain complicated science in a way that makes sense, which makes him important for talking about space stuff and what it means for us. Kaku says we need to keep watching and using models to guess what might happen in space. He thinks it's important to study how planets pull on each other, not just because it's interesting, but because it matters to us. He also thinks we should be ready for anything that might happen. He and Tyson agree that space is full of surprises and that we still have a lot to learn. We need to keep exploring and using models to learn more about the universe. The idea of Pluto and Neptune crashing shows how hard and exciting it is to explore space. It means we need to use good science, new tech, and be ready to change what we think as we learn more. Tyson and Kaku want scientists and everyone to keep pushing the limits of what we know. Most scientists agree that Pluto and Neptune's orbits will stay steady for a long time because of how they move together and the gravity that's affecting them. So a crash is very unlikely. But because things can change, scientists need to keep watching and studying these planets to see what might happen in the future. Even though it's not likely, the idea of Pluto and Neptune crashing shows how important it is to keep exploring space. New tech, like better telescopes and computer models, will help scientists make better guesses and keep us informed about our ever-changing solar system. Tyson and Kaku both want us to keep learning and be open to new ideas. The idea of a crash, even though it probably won't happen, shows how wild and complicated our solar system is. It reminds us that there's still a lot we don't know. How could that even happen? What would it mean? Is it just some weird space thing? Or is there more to it? Let's check out what could happen if Pluto and Neptune got too close. Pluto got bumped from planet status to dwarf planet because its orbit is kind of strange, but scientists still find it interesting and keep studying it. Recent predictions say Pluto's orbit is getting pretty close to Neptune's. Tyson and Kaku are worried about a crash, which sounds bad for Earth. So how could this happen? Pluto takes a super long time to go around the sun, like 248 years. Since we spotted it in 1930, it hasn't even made one full trip. Plus, its path isn't a circle like the other planets. It's more of an oval and it's tilted too, making things even weirder. Here's a crazy fact. For about 20 years of its orbit, Pluto is actually closer to the Sun than Neptune is. So why haven't they bumped into each other? The answer is gravity from other planets. When Pluto was first spotted, scientists wanted to figure out its weird path, especially because it's so tilted and oval-shaped. The mystery got deeper when they realized it crosses Neptune's path. The fact that Pluto's orbit is steady, even with all this, tells us a lot about how space stuff works. Think of it like this: you have Pluto, Neptune, and the Sun, all pulling on each other. It's hard to guess where they'll go based on where they start and how strong their gravity is. For Pluto, this helps explain its wobbly path. Astrophysicists say that something called azoth libration keeps planets apart. For Pluto and Neptune, it means that when Pluto crosses Neptune's orbit, it's always far away from Neptune itself. Another thing, scope libration, means that when Pluto gets close to Neptune or other big planets, it's always above their orbit, which helps avoid crashes. There's also something called Vic-zip oscillation. It sounds complicated, but it just describes how Pluto, Neptune, and the Sun tug on each other. This helps keep Pluto's orbit steady, even though it looks messed up. All these things help keep Pluto from crashing into Neptune. They show how these pulling forces switch around depending on where the planets are. Back in the 80s, some math showed that Pluto's orbit is still a bit wild. Tiny changes could make a big difference over time, But these weird things about Pluto's orbit seem to keep it steady for a very, very long time. New computer models help us understand how big planets like Neptune, Jupiter, and Saturn mess with Pluto's path. Neptune and Pluto have a special thing. For every 2 trips Pluto makes around the Sun, Neptune makes 3. Jupiter's pull also helps keep Pluto on track, strong enough to keep it steady for billions of years. So Neptune, Jupiter, and Saturn all team up to keep Pluto safe. Without these things, space would be way more chaotic, with stuff crashing into each other or flying off into nothing. Understanding Pluto's orbit is super important, especially with all this talk about it hitting Neptune. It shows us how things that look unstable can actually balance out. We should keep watching and learning to understand our place in space better. Space is weird, and Pluto's orbit proves it. Orbital chaos means that even small changes to where Pluto is or how fast it's going can totally mess up its orbit over time. Scientists use computer models to see how Pluto moves. These models use math to show how Pluto and planets like Neptune pull on each other. Even tiny tweaks in the models can create totally different results. Back in the 80s, these models showed that even with those things that keep it steady, Pluto's path can still be crazy. A small change could lead to a very different orbit way down the line. But even with all the chaos, Pluto's orbit stays pretty stable for billions of years. It can be hard to guess what will happen with orbits like Pluto's. We can never be totally sure about things. So, the models are good, but they depend on knowing exactly where things are and how they're interacting. Even a small mistake can throw off the whole prediction. The craziness of Pluto's orbit reminds us that space is unpredictable. We've learned a lot, but there's still a lot we don't know. Getting at how the big planet's gravity affects Pluto helps us understand how the solar system works. It shows how each planet can change how other planets move. So why are Tyson and Kaku talking about a crash now? Tyson sees Pluto's weird orbit as a sign of how much more we have to learn about space. Kaku thinks we need to keep watching and modeling to guess what might happen. He wants us to be ready for anything. Tyson and Kaku both agree that space is full of surprises. Our knowledge is good, but we can always learn more. This possible Pluto-Neptune crash shows why we need to keep exploring and figuring things out. Most scientists agree that Pluto and Neptune's orbits will stay steady for a long time because of how they move and the gravity pulling on them. A crash is super unlikely, but because things can shift around, we need to keep watching these worlds and learning what they might do in the future. Even though a Pluto-Neptune crash is probably just a theory, it shows why space exploration is important. Better telescopes and computers will help scientists make better models and keep us in the loop about what's happening in space. Tyson's thoughts on Pluto and Kaku's focus on the unexpected remind us to keep researching and stay open to new ideas. This possible crash, even if it's unlikely, reminds us that space is wild and complicated. We need to keep trying to solve these puzzles and expand our understanding of the universe. As we continue to study Pluto, it's crucial to remember that our understanding of space is still evolving. The more we learn, the more we realize how much we don't know. Even though we've sent spacecraft like New Horizons to explore Pluto, there's still a lot of mystery surrounding this distant dwarf planet. As technology advances, we gain new insights, and these discoveries often lead to more questions. For example, even though Pluto was demoted to a dwarf planet, it still holds a significant place in our solar system due to its unique characteristics and behavior. One of the most fascinating aspects of Pluto's orbit is how it interacts with the other bodies in the Kuiper belt. The Kuiper belt is a region beyond Neptune that contains many small, icy objects. Some scientists believe that studying Pluto and its interactions with other Kuiper belt objects could help us learn more about the early solar system and the formation of planets. These objects hold clues about the conditions that existed billions of years ago when our solar system was forming. By understanding how Pluto's orbit fits into the larger context of the Kuiper belt, we may uncover more information about the history of our cosmic neighborhood. Additionally, some researchers are also interested in how the behavior of distant objects like Pluto may provide insights into the dynamics of other planetary systems. Many exoplanets are discovered in distant star systems, and by comparing these systems to our own, scientists can better understand the forces at play. In this way, Studying Pluto can help us build a more complete picture of planetary formation and evolution not just in our solar system, but throughout the galaxy. With each new discovery, the story of Pluto and its orbit becomes a valuable piece in the puzzle of our universe's history. Pluto's orbit is a prime example of how complex and dynamic our solar system can be. While many focus on the possibility of Pluto colliding with Neptune, it's important to recognize the delicate balance that allows for such a seemingly chaotic orbit to remain stable over time. This intricate balance between gravitational forces, orbital resonances, and physical properties of the planets and dwarf planets shows just how interconnected everything in space truly is. The unique dynamics of Pluto's orbit offer a window into the fundamental forces that govern our entire solar system. Additionally, the potential impact of Pluto's orbit on future space exploration is another aspect worth considering. As we develop more advanced telescopes and space probes, we may gain even deeper insights into Pluto's environment and its long-term trajectory. These missions could help scientists better predict how other distant celestial bodies might evolve over time. For instance, we may learn more about the outer reaches of the solar system and how objects interact in these far-flung regions, shedding light on the influence of distant forces on the bodies within it. Moreover, Pluto's potential influence on future missions beyond our solar system, such as those studying exoplanets or distant stars, cannot be overlooked. The study of celestial mechanics, including Pluto's interactions with other planets, provides a better understanding of how distant stars and their planets behave. As we venture further into deep space exploration, understanding the gravitational influences and orbital mechanics in our own system will help refine the tools and strategies we use to study alien worlds, some of which may possess similar gravitational and orbital characteristics. The ongoing study of Pluto and other distant objects highlights how space is full of surprises and how much there still is to learn. The mysteries of our own solar system help lay the foundation for even greater discoveries beyond our immediate neighborhood.